All right, we are doing all of our polynomial theorems today. So we got 2 of them. Actually, we're going to do 2 of them today. I lied. And 1 of them tomorrow. Today, we're going to do the rational root theorem and the conjugate root theorem. Tomorrow, we're going to do the remainder theorem. Okay? They sound very fancy, but they're pretty not. They're pretty simple. Okay? A theorem means it happens all the time. It's been proven that it will always be true. Okay? So what we're going to do is we're going to list possible roots. That's what the rational root theorem is going to do for me. And then we're going to find the roots of a function. And then we're going to use the conjugate root theorem to find other roots. So they're all helping us find roots. So first off, rational root theorem. Okay. It is used to find all potential roots of a polynomial. Okay, that's how we use it. There we go. So what do we need from our polynomial to use to do this? What we're going to look at is we are going to look at the coefficient and the constant term. And constant term. Okay? So if we are in standard form, it's the first and the last piece. Okay? So that's why I kind of brought up standard form going over your homework. Standard form means exponents going from highest to lowest. If we're in standard form, it's our very, very first piece and our very, very last piece. Okay? We are going to use the positive and negative for each factor. Okay, so what we're essentially doing is we're listing all the possible places that your polynomial could cross over the x-axis before we solve and figure out which one it actually is. Okay, so the rational root theorem, you make a list of possible solutions of where it's going to actually cross the x-axis. Okay. We are going to, it's p's over q's. So you're going to do positive and negative p's over positive negative q's. The p's are the factors of the constant. Divided by positive and negative q's. Those are the factors of, I'm going to say LC for leading coefficient. Leading because it's first. In standard form, it's the first coefficient. All right. So we have 3x squared plus 5x plus 2 equals 0. Okay. We're equal to 0. We're trying to find roots. It's in standard form because my highest exponent, which is a 2, is first, and then it goes in order after that. Okay. P's over Q's. So our constant, our factors of our constant over the factors of our leading coefficient. So I need positive and negative factors of 2 divided by positive and negative factors of 3. Okay, well, what are the factors of 2? Just 1 and 2, right? 1 and 2. What are my factors of 3? Just 1 and 3. This is how you set it up. This is not a list, right? I got numbers divided by numbers. It's not a list yet. You got to actually do the dividing. So we have positive and negative 1 over 1. So that's just going to be positive or negative 1. Then I'm going to do 1 divided by 3. Positive and negative 1 divided by 3. Then I do it again with 2. 2 divided by 1, okay, positive and negative 2. And then 2 divided by 3, positive and negative 2 over 3. That is your list. This is your list of the possible places that this polynomial is going to cross the x-axis. How many possibilities do we have? Don't say 4. 8, right? It could cross the x-axis at 1, or it could cross at -1. It could cross at 1/3, or it could cross at -1/3. We see that? We have 8 possibilities. So why are we doing this? Because before we do this, the list of possibilities is literally anything, right? Negative to positive infinity, it could cross anywhere. You didn't have any way of kind of narrowing it down. This is going to help us narrow it down, okay? Especially when we have polynomials that you can't factor right away because they're not a degree of 2, okay? So if we have like a degree of 3, a degree of 4, fun fact, synthetic division is going to come back. And we're going to use this list with synthetic division to break it down so then we could factor. Okay, so it's all going to come together. Okay, do you think you can do the next one? I think you can. We have 2x cubed minus x squared minus x minus 3 equals 0. It's equal to 0, so we know we're getting roots. It's already in standard form because we have our exponents in order, highest to lowest. So you find your P's and Q's, set it up, and find your list. All right, check with me. How did we do? We're good? P's and Q's. This is your P, this is your Q. If you're ever not sure which one comes first, by the way, the queen is always in front of the prince. So the Q is first, the P's on the end. Queen before the prince, okay? Our factors of 3 are positive and negative 1 and 3. Our factors of 2 are positive and negative 1 and 2. 1 divided by 1, 1 divided by 2, 3 divided by 1, 3 divided by 2, okay? How many possible places is this polynomial going to cross over the x-axis? There are 8 possible places. Good. So, next question, does the plus and minus matter? Yes. If you just have a list of those without the plus minus signs, you're literally leaving off half of the possible roots of your polynomial, okay? So don't get mad at me when I take points away because you didn't put plus minus. You're leaving out an answer. I have to take points off, okay? Here we go. What are the rational roots of the following polynomials? So what we are going to do, this is where it's all going to come together, okay? And if you have a graphing calculator, your life is going to be so much easier. So I'm going to give you a second to get a graphing calculator if you do not currently have one at your desk. While you get that, I'm going to write these down, and then I'll talk about it when you write them down. Okay. So while you're writing these down, I'm not talking about them. Okay. So how are we going to use rational roots, the theorem, to find all of the x-intercepts of my graph? Okay. The first thing you're going to do is you're going to break down your list from infinite to just the list of 8 or 5 or whatever. Okay, list all possible rational roots. This is your p's over q's. So we always do this first. Positive and negative p's over our positive negative q's. We're going to make a list of where it could happen. Step 2, depends if you have a calculator or if you don't have a calculator. If you don't have a calculator, okay, you're going to have to plug in each number from your list into the equation and see which one makes the equation equal to 0. That makes it a root. Okay, if you have a graphing calculator, we are going to graph it and physically look at the graph and see where it's crossing the x-axis. Okay, so you don't have to test if you have a graphing calculator, but it's not impossible if you don't have a graphing calculator. Okay, but we have the tool, so I'm going to teach you how to use it. Deal? Looking at a graph does not prove that it's a root. We're going to look at the graph. We're going to assume it's a root. And then in number 3, the way we prove that it's going to work for us is we're going to use it in synthetic division. Okay, that becomes our basketball or the number on the ledge. Okay, the number from our list becomes the number in our synthetic division. After we divide, we better have a remainder of 0. That's what proves that it was a root. And then step 4, we should have broken it down to a quadratic function to where we can then just factor to prove the other ones. Okay, all of my answers should be in my list from number 1. If I get any number that's not part of that list, we messed up. Okay, the one right above this, if I solved that and got x equals 4, that is wrong. It's not in my list. It can't possibly be a root. Okay, so all of our answers need to be from our list. All right, ready to put all this together? Yay! Parker's ready. Okay, here we go. We have 15x cubed minus 32x squared plus 3x plus 2 equals 0. It's already equal to 0. We are solving for my roots. Okay, first thing I do is I got to make my list. Okay, I need factors of 2 divided by the factors of 15. So what are my factors of 2? 1 and 2. What are my factors of 15? 1, 3, 5, and 15. The list is going to be a little bit longer this time. All right. So let's make my list. We're going to have positive and negative 1 over 1, positive and negative 1 over 3, positive and negative 1 over 5, positive and negative 1 over 15. Doing it again, but now we're going to do 2 divided by all those numbers. Positive and negative 2 divided by 1, positive and negative 2 divided by 3, positive and negative 2 divided by 5, positive and negative 2 divided by 15. All right. So how many possible places did we just reduce infinite to? Yeah, 16. There's 16 possible places, okay? If you don't have a graphing calculator, you would start plugging these values into the equation. My suggestion would be start with the whole numbers. Plug in 1, plug in negative 1. Plug in 2, plug in negative 2, okay? And then if those don't work, then start messing with your fractions, okay? But if you have a graphing calculator, let me pull it up. Where is it? Here it is. Okay, we are going to graph it. What button do you push to graph something? Y equals. So go ahead and push Y equals, please. Remember when I push it, it turns red. If you have stuff in there, push clear. We don't need all this. Get rid of anything that's in your way. So the first one we're going to do, let's see, 15. Remember, our variable x is next to the alpha button. And then we're going to raise it up using this caret key to the power of 3. Make sure you get out of your exponent. Push the over arrow if you need to. Now we have minus 32x squared we have plus 3x, and we have plus 2. We don't need to put equals 0, okay? That part we don't need to plug in. We're just plugging in the function. The equals 0 on our paper shows we're finding the solutions, okay? That's when y equals 0. Those are my x-intercepts. Do we have that plugged in? Okay. How do we? So it is user error. You did not type something in the right way. So you do something wrong in your y equals. I'll come to you here in a second. Everyone else, I'm going to come to you. Everyone else push graph. If your window is weird, like mine, do we remember how to make it go back to the 10 by 10? Zoom 6. Yes, push the zoom button, the top middle. And if you go back and see how 6 is standard, it's the standard 10 by 10. And it'll show you these. Okay. Okay, so looking at my list, which x value looks like it's going to be an x-intercept? Which very nice x value looks like it's going to cross? Even better than that. 2. You see that? Looking at my graph, does it look like 2 is going to work? Yeah? Possibly 1/3, maybe negative 1/3. The decimals are hard to see on graphs, right? We're not really quite sure. But I'm pretty positive that that's a 2, and that should work for me. Again, we're assuming, so how do we prove it? Synthetic division. Okay? So bring this back up. So we are going to test. Okay? We're going to use what we got from our graph. So we're testing the 0 or the solution of 2. Synthetic division, we use our coefficients. Our variables are already in order. We're not missing anything. I don't have to put a 0 placeholder anywhere. We're going to do 15, negative 32, 3 and 2. We drop the first guy down. We set it up. We're setting him up for his free throws. And now we're going to bounce the basketball. What is 2 times 15? Positive 30. Remember, bring the sign. That's how we know if we add or subtract. All right, what is negative 32 plus 30? Negative 2. Bounce the basketball again. What is 2 times negative 2? Negative 4. What is 3 minus 4? 1. Negative 1. Bounce the basketball. What is 2 times negative 1? Negative 2. 2 minus 2. Oh, look at that. We just proved that it is a root. It is a factor. So 2 is definitely part of my list. I can already say x equals 2. Okay. Ooh, bonus question. How many answers should this have? How do you know it's 3? Yeah, you're right. It's a cubic. Yeah. Good. And did you look at the graph? Did it cross over 3 times? Yes, it's going to have 3 answers. Okay, so we know 2 is one of the answers. How am I going to find the other ones? What does step 4 say? It says factor, because now we have 15x squared minus 2x minus 1. We've reduced it down an x. We've taken an x out. So instead of x cubed, now it's x squared. How can I factor this? What method are we going to have to use? Slip and slide or cloud. So let's slip the 15 to the end. That gives me x squared minus 2x minus 15. Basic factor. What multiplies to give me negative 15 but adds to give me negative 2? Negative 5 and a positive 3. Good. We are not done. Now we're going to slide and divide my 15 back out. 5 over 15 simplifies to what? 1 over 3? And this simplifies to 1 over 5. I don't have to bump it up. We want to solve for x, right? If I make both these equal to 0, all I got to do here is add 1/3 over. This gives me a positive 1/3. Here, subtract 1/5 over. This gives me negative 1/5. Did that make sense with the graph you just saw? Yeah, we definitely assumed those were going to be decimals, right? So it makes sense, again, make your math make sense, that we have fractions for my other ones. Are these on my list? Is positive 1/3 in my list? Yes. Is negative 1/5 in my list? Yes. So those are all of your roots. So we have x equals 2, 1/3, and negative 1/5. And they're all in my list, so we know that they are right. And looking at my graph, that does make sense. So for my visual people, the calculator will help you actually see it and see what makes sense as well. All right. We good? Okay. For time's sake, I want to go down and do the next theorem. If I have time, I will come back to do the other one. Okay. So we're going to talk about the conjugate root theorem. Okay. So my conjugate root theorem tells me that if we have a plus bi, if that is a root, then a minus bi must also be a root. Okay. Think about it. What do i's come from? Negative square roots. When we square root something, don't we always have two answers? A positive, negative something? So if I got a root that had an I took the square root. He should have a friend. He should have a partner. Okay. So that means if I had 4i as a solution, what also had to be a solution? We had to also have negative 4i. Okay. What if I had 3 plus the square root of 2? What had to also be an answer? 3 minus square root of 2. So it comes with i's, which also comes from square roots. Okay. So if we have an I or if we have a square root involved, there has to be two answers, a positive and negative of the two. Because what we're about to do here is we're going to work backwards. I'm going to tell you where the graph is crossing our x-axis, or I'm going to tell you the solutions of the polynomial. You're going to tell me what the polynomial was to give that to me. Okay. So if I have an equation that when I solved for x, I got x equals negative 4 and x equals 2i, what also had to be an answer? Negative 2i. The i's come in pairs. Negative 4 is just negative 4. Nothing special about it. Love it, but not special. Okay, our i's are special, our square roots are special. So this had 3 roots. So when I find my polynomial, what degree should it be? It should be a degree of 3. We should have a cubic when we're done. Okay. So we have x equals negative 4, we have x equals 2i, and we have x equals negative 2i as my intercepts. We're working backwards. So how do I take my solutions and put them back in factored form? We got to bring it back together with its x. They're going to make up. So if negative 4 gets back with its x, this becomes x plus 4. If 2i gets back together with its x, this becomes x minus 2i. This becomes x plus 2i. So you're moving it back over the equal sign. We're doing the whole thing backwards. Factoring was division. If I'm going backwards, what am I going to do with these guys? We're going to multiply them. Okay. I'm going to multiply the i's together first because I remember when I multiplied conjugate with i's, didn't the i's go away? Yeah, let's do it. X times x, x squared, there we go. X times 2i, 2ix, negative 2ix, well, negative 2ix, there we go. Negative 2 and 2 is negative 4. I and I is I squared. That's a lot of pieces. Or is it? What happens? My 2ix's cancel out. Turns into a positive 4. Good. This becomes x squared plus 4. Because I squared is negative 1. So that's negative 4 times negative 1. Am I done? Do I have a polynomial with a degree of 3? Not yet, so we're not done. So what do I have to do now? Yeah, keep multiplying, keep distributing. All right, x times x squared, x cubed, x times 4, 4x, 4 times x squared, 4 times 4, 16. It's all nice and dandy, but my math heart doesn't like it because it's not in standard form. So I'm going to write it in standard form. What should go first? X cubed, that's good to go. What should be next? There you go. Then what? And then 16. Do I have a polynomial with a degree of 3? Yes. So we went backwards. Instead of me giving you the polynomial and saying solve, it was already solved. I want you to tell me, where did it come from? What's up? Yeah. Jude asks, is this one going to have 4? The answer is yes, because this is 2i and negative 2i. This is square root of 2 and negative square root of 2. So this is x minus 2, I, plus 2i. This is minus square root 2. This is plus square root 2. When that goes back in the parentheses, it changes its sign. That's an ugly 2, like that. Okay. Use the conjugate theorem that we've already used. We know if I have conjugates, my middle pieces cancel, right? So you don't have to keep finding your middle pieces if you know they're conjugates. These are conjugates. All I have to do is x times x, which is x squared, and then negative 2i and positive 2i to get negative 4i squared. This is x squared plus 4. Don't make yourself do more work. Use the knowledge you already got. My square roots, they're also conjugates, right? Positive and negative are the exact same thing. I don't need the O and the I in FOIL. They're going to cancel. We can do first and last. X times x is x squared. Negative square root 2 times positive square root 2 becomes negative square root 4, which is what? A 2. All right? Then what do we do from here? Multiply. Yep. X squared times x squared gives me x to the power of 4. X squared times negative 2 is negative x squared. 4 times x squared is 4x squared. That's nice. 4 times negative 2 is negative 8. Is that my answer? Am I done? I have a degree of 4. No, why not? Yeah, combine those pieces in the middle. So this is really what? X to the power of 4 plus 2x squared and then minus 8. Like that. Good. Okay. How many solutions is the last one going to have? 3. Good. Which one's not listed but should be? Negative 5i should be listed right here. Good. If you're doing this one, I'll show you. You should get x to the power of 3 plus 4x squared plus 25x plus 4. And if you are practicing this example up here that we skipped for time's sake, you should get, looking at your graph, you should see that negative 1 is a clear crossing point on the x-axis. Use that for synthetic division. And then the other two you get after you factor should be 1/4 and 1/2. Okay, so if you want to use those to practice, you can. You also have a practice worksheet. But at least those, you know what the answer should be, right? So if you want to do those first, make sure you know what you're doing, and then go to your worksheet, you can. What's up?